actually watches the video?
No.
Okay. There
So,
we go.
are we
Just
make
make sure
Are we
everybody's.
all supposed to like post the video? I thought only one of us.
No,
Because mine
so-
always like where it says you have stuff due on that week, whatever. It always says one because I never submit anything to
You
the
just
group.
what I did.
You just say done or whatever.
Well, I just put a period on it.
Oh, a period.
If you just do like little comments, they'll go away. You know.
Okay, so it's like the same thing as always, right? We go over the preparation assignment, and then we go do the quiz.
What group? Is there a group preparation? I think we already did the group.
Well, we just individual preparation, and then meet with your group.
Yeah,
using
yeah. So now
Google
we
Hangouts,
just do
discuss any questions you have on part 2.
Oh, did you guys have any questions? I felt like it was pretty self-explanatory. I think the only thing that I would probably I think we'll remember together is the whole thing where he did the standard deviation and the variance.
Yeah, it seemed kind of
Just like, what are you doing? Okay. Cool.
like it said on the video, like this part has been de-emphasized in the course, so I don't know what that meant. But on the video, he was doing like the standard deviation of like a random.
Well, so he found the
random
variance, and then he did, and then he did like the square root to get the standard deviation.
Mhm.
But I can't remember what he did to get the variance exactly. He did.
It's the number.
Well, it's the variance is off of the mean, right?
Yeah. Oh, okay. So that's what it was. It was the number minus the mean.
The probability or whatever it was.
Yeah, it's the mean, and then you square that, and then there's something else. Or maybe you just square it and that's it. I can't remember.
You square it and then divide it by something.
And then eventually you take the square root. Well, you take the square
root. Well, the square root is to get the standard deviation.
But I wonder if it's bad to use because you can use the standard deviation formula in Excel to get it a lot quicker.
Yeah.
And it's
accurate. But I think they want us to, do something by hand with that board. No, I don't think it's her.
She's looking around like it might be her.
Yeah, she was looking around. Maybe she'll pick her. She looks kind of
I knew it. Yeah, and then so the discrete random variable.
And that was the only thing.
So a variable is something that varies, and a variable is random if it follows a specific distribution. See, like that, their definition of random was weird to me. It's like it follows a pattern. Well, because I know that random things follow.
It's random if you just look at it in the short term, but then so you don't know what's going to come next.
So you can't predict.
But if you can see the long term, then you can see that there's a pattern. That's what they were saying.
Oh, okay.
Yeah. Okay.
So it's discrete if it could be listed in principle given enough time. So a discrete random variable is something that could be like a variable that could be listed, or that its values could be listed. Then you can't predict the outcome and see a pattern in the long term. And then a variable just means that it's changing.
Something like that.
Yeah.
Let's start the quiz because we have unlimited tries, right? So we have 2 tries.
You have 2 tries.
Well, we'll be fine. Let's just do it. You guys ready? Don't. Okay. I completed. When you required to work together, okay. Give all the proper answers. Do not.
I completed an individual preparation assignment before attending.
The blood types and proportions given me find the probability distribution. You guys remember what that is?
Classified into one of our basic types, or be proportional people in the population of the United States. Each of these blood types is summarized in the following table. The blood types are proportional, and the proportions given in the table define a probability distribution. Well, because in order to do that, you'd have to use the 3 different rules, or at least one of them. If that adds up to be 100, or it adds up to be 1 probability distribution.
Okay,
but it doesn't look like it does.
No, I think it does. Let's see. So that's 80. No, you're right. Wait, no, I think it does. It does. So 45 plus 40 is 85, right? Then you add the 4, so that would be 89. You add 11, and that's 100, so that's 1.
Yeah. Okay.
So true.
So at least under that principle,
Oh.
does it break any of the other rules?
It's
I
got to
still don't
be in
know if we can
between
use notes
0
on this
and
or not.
1, right? It can't be a negative, and I'm pretty sure it's good.
And the sum of it has to equal 1.
Some has to equal 1.
It
I'm
can't be
pretty sure we're good to
100%.
go. What is the probability that randomly select a person who has a typo? So we look at typo.
0.45.
Yeah, that's literally like looking at the graph and just. All right. What is the probability that randomly select has typo? But wait. That will
51.
not. So it would be
55. 0.55,
It would,
I
yeah,
think.
0.55. It would be the opposite. So it'd be 1 minus.
Oh, yeah, 1 minus. That's the simpler way to get to
Yeah.
it.
All right. So now we're on 6. Are you on 6 now?
Yeah.
Okay.
So my computer's-
Carolyn
0.55
Willis.
you said?
Yeah. So it's basically what it is to get it, and then you do 1 minus what it would have been to get it,
Oh,
right?
okay. Yeah.
Because it's the opposite. Carolyn and her colleagues conducted a study in which dogs were trained to detect bladder cancer.
That's
Interesting.
bizarre. Yeah.
Dogs were trained to lie down next to the specimen derived from a bladder cancer patient. Tangle, one of the dogs, demonstrates the identification of a specimen. 7 bowls containing urine were lined up in a random order. 6 of the samples were for patients who did not have bladder cancer. 1 of the samples came from a person who identified the bladder cancer patient. Yeah, if the dogs guess at random, what is the probability that so it would be 1 out of 6. So what would that be?
7 bowls were lined up.
Oh, there's
in
7,
random
not
order.
6.
6 of the samples were from patients that did not have bladder cancer.
Yeah, so it'd be 1 out of 7.
1 of the samples came from a person that
1 divided by so 0.143. All right, moving on. In a combined total of 54 trials, dogs correctly identified the specimens from the cancer patient 22 times. Is there any likely the dog will do this well by random chance alone? Which of the following statements is most appropriate? This provides strong evidence. Oh, I can't remember this. What does it have to be able to be strong evidence?
know if they specifically said.
Yeah, as far as I remember, it's just
Because it's like,
based on.
So
I mean,
what
that
they
means-
said is they identified the specimen. 22
well,
patients.
we could compare that though. So like 22 out of 54 times is 40% of the time. What would be the probability that they would do that, or they would guess right otherwise? So it's like, so we're saying it'd be 0.143, right?
Wait, how did you get 0.143?
Because that's the one above. So it's like 1 divided by 7 is like the probability that they're going to guess anyone right over a long period of time.
Oh yeah.
If there's only one. So it's like if they're doing it 40% of the time, and really the probability is 14% of the time, then that means they're doing like,
Well, so I get what you're saying. The thing is, the probability of them guessing it is 1 out of 7, right? But that's just guessing randomly.
yeah,
Since
but
they've
that's,
been trained, I don't think we really need to apply that because I don't feel like it applies.
well, I'm just saying like if it was completely random,
Mhm.
if they couldn't detect that there was cancer in it or whatever, then they'd be able to do it 14% of the time just normally.
Oh, and then they were able to do it 40% of the time.
So which is strong evidence that they can detect at least,
There's strong evidence that there's a difference.
Yeah,
Yeah, I'd say so.
because there's
We're gonna
not
get
little
it wrong.
evidence that because there would be little evidence that
It's
they
true.
could detect
If it
bladder
was
cancer
like
if it was 14%
barely,
or less.
if it was like 15%, maybe
They're
it'd be
higher than that.
Yeah, so they're above that. So I think
that's true. I agree now. Sorry, I just wasn't catching your train of thought.
no. So
If you reach into a bag, what is probably drawing a red M&M? It is 20.20, right? Oh no, red. Sorry, 0.13. Wait,
I think
round
so.
the
Is
answer?
that too easy?
No, it says round the answer. Why would we have to round the answer?
let's see. So M&M's are small.
Oh, see, those aren't actually the probabilities. Those are the proportions. Whatever that means. So would that mean that like? I'm so confused.
Oh, is this where you times it by? Do you know how many are in the bag? No. Okay. So
Well, I'm just thinking that if those are the proportions, that would mean like watch, for example, 1 minus 0.13 minus 0.14 minus 0.13 minus 0.24 minus 0.2. So that means that there's 6.16 for the green, because you see how it's crossed out? We don't know. But we know it's got to all equal 1, right?
Yeah, I'm just,
So we know at least that now.
yeah, so let's see. So point, because I think this is where you, like, because they times some stuff.
I'm so confused, actually. That doesn't make sense.
Is that yellow?
Yeah, that's
so
yellow.
funny.
I mean, because in question 4, it was the same exact thing. It was like, what is the probability that the person has type O blood, and we just put 0.45,
Maybe we did that
which is exactly what the proportion was.
Let's see what.
I don't know if
Well,
we did that
we might have
wrong.
done it wrong on that one too.
Well, I don't know, because I think you'd take,
Well, because
in a
if you take a
perfectly-
look at what he was saying, this is what we did here, and we literally just took the numbers. It says the exact same thing
Maybe
on that
if we
table.
did it wrong.
up there, then
Well, yeah, if you think we did it wrong on this one, then we did it wrong on that one too.
Yeah.
This is the same exact question.
Yeah, the proportions.
I mean, it kind of does seem like too easy to be true, though.
what is
It kinda seems like
the probability?
So what
Well,
this
okay,
is,
so-
is what is the probability, and then what are we trying to find down here? The same thing, right?
same exact thing.
What is the probability? They're both probability.
Well,
It's like the proportion is what we took from it before.
But it doesn't make sense that they would like have us do it up here and then like get further into it and then have us do it the exact same thing. I'm a little confused.
But okay, but let's think about the actual, like, the problem itself. So if you have a bag and there's like equally distributed, then it's going to be 1/6 of the bag, right?
Mm-hmm.
Or it's like, so if you have
But
6
it's
things,
not.
so but this is not equally distributed, but it's like the same thing though, because it's like you're just saying instead of 1/6, like, oh, we know that there's 0.13 brown and there's 0.14.
So what
Yellow.
you're saying is if you take
And then
1/6 and then you times it by 0.2, 1
Well-
divided by 6.
well, I'm just saying, like, instead of 1/6 of the bag, you have 0.13 of the bag. That's it. So it's like the same logic to it. So I don't know why they'd be asking it twice, but it seems like,
You think it would just be 0.2?
because like otherwise, what
I don't know why else it would say round answer to 2 decimal places if you literally just put in what's right there.
Well, I mean, it says round to 2 decimal places up there, but like there's 2 decimal places on each of those answers.
Well, let's just do it, and then
You're
next
saying
time
do
if we get it
0.13.
wrong, then
Yeah.
we'll try to figure out what we did wrong.
Into a bag of plain M&Ms, what is the probability of drawing a red colored candy?
Maybe what the trick is they're trying to remind us that there's 1, so that's why they didn't give us the green. Because I had to calculate that, right? I had to do 1 minus. So it's 0.16 for green.
Because I just can't think of any other way that you would calculate the probability of that. That would be different than the
Yeah.
exact
Yeah.
proportion that you
So
have.
number 9 would be 0.16 because you take 1 and you minus everything that it shows. Is not green, so you would do that would be 8.84, which would be 1 minus. Is the following the answer? ACT scores students admitted to medium-sized public university in Western United States were taken from CAPEX. The following summary statistics were calculated. Okay. Half of the observations are less than or equal to what
Wait,
number?
it's probably-
Half of the observations would be the median, right?
Median, yeah.
Wouldn't
so
that be 24?
The X score,
Yeah, because remember when we were looking at that, the quartiles or whatever, you have the min, the max, then you have the median in the middle, and then you have the Q3 and Q1.
yeah, because you have
Yeah.
those 4 numbers.
So the
minimum.
one, so this is, if you have max here, then Q1 would be 25%, and the middle would be 50, then 75. So it would be 24, I believe. Based on information, the top 25% is what's scored above what number? So if that is true, then
Q3, right?
it'd be either
So, yeah,
Q3.
27.
I don't know if I've mixed them up because I remember last time I was doing the homework, it was like I might have mixed them up, but I think it would be Q3.
It'd be Q3 because it's a higher number. Yeah.
27. Oh,
Which is following the same.
yeah, that makes sense. Last one. Which of the following is not one of the three rules? Probability that an outcome will not occur is 1 minus. Probability is a number between, yes, but the probability is high and the
It's the
probability is
negative one.
It's
positive.
the third one.
The sum of the probabilities. Oh,
Well, I'm assuming
negative.
it's-
Obviously, it can't be
Yeah.
negative because it can't be negative. All right, guys. Moment of truth. Oh, baby, show me the money. I have a feeling we got some wrong. Okay, so number 1, 100. Number 2, 100. Here it is. Number 3, we got that right.
We got 100. Yeah.
Oh, wait, I got one wrong somehow. What did I do wrong?
I got 150. Just kidding.
What did I put wrong? Maybe I missed a question somehow. Wait, I put,
Yeah.
oh, my freaking dyslexia, idiot. I put 0.2 for orange for red instead of 0.13. That's why, but yeah, I'll just do it again and I'll get it right. Cool. Well, that's all we really have to do. We're good to
I guess
go.
I'll show everybody again at the end of the video, just in case.
Laura's,
Laura's non-existent.
she doesn't like us, guys. Sorry.